Okay, in this lecture we are going to discuss what are the operations can done on the lathe machines. Okay, the various operations can done on the lathe machine, but we are discussing only the one of the most common operations done on the lathe machines. Okay, the knowledge about these operations can done on the lathe machine you should have. That's why we are discussing this topic. Some situation you may use these operations for your workshop practical sessions also. Okay, let's move to the theory of this topic. Okay, in this lecture we are going to discuss the main operations. What are the operations can done on lathe machine? That means the lathe operations we are going to discuss. Okay. Okay. Then the first lecture under this lathe machine, we discussed the classification of lathe machines. Then we discuss, we identify the component of the lathe machine. Then we are going to discuss lathe operations. These operations we are going to discuss based on the engine lathe, commonly using lathe machine. The first one we are going to discuss. First I will introduce this operation, then we can discuss each and every. Yeah. Okay. First operation I am going to introduce. Okay, I will throw it in here. Turn-in operation. Okay. The turn-in operation. This operation is called turn-in operation. I will draw the cutting tool also. Okay. This operation is called turn-in operation. Turn-in operation. Okay. Turn. Then next operation is face-in operation. Okay. Next operation is face-in operation. Later we can discuss in detail about these operations. Okay. Face-in operation. Cutting tool, I will draw the cutting tool also. This operation is called face-in. Face-in operation. Next one, turn-in, face-in, taper turn-in operation. Okay, this operation is called taper turn-in operation, generating a conical shapes. Generated in this kind of conical shapes called taper turn-in operation. I will draw the cutting tool also. Taper turn. Then next operation is profiling. This turn-in operation is called profiling. It generated this kind of shapes. With the cutting tool. Operation is called profiling. turning, facing, profiling. Then the external grooving. This kind of narrow tool is used for external grooving. This is called external grooving. External grooving. Then the face grooving. Okay. This operation is called face grooving. Face grooving. Okay, next one, bore-in operation. The bore-in operation is used to enlarge the existing hole. Okay. The bore-in operation. The bore-in tool is used for this bore-in operation. Here, this is called the bore-in operation. Next one, the center drilling operation. Okay, drilling. Generating a hole along the rotating axis of the lathe machine. Okay, center drilling operation. This is the cutting tool. Drill bit is used for center drilling operation. This is the cutting tool. Okay, center drilling. Center drilling operations. The next one, center drilling, boring, then the form turning. Okay, cutting with form tool. To generate this kind of irregular shapes, let's take we want to cut this kind of shapes, these faces. Okay, this is the cutting tool we are use for this one. This one is called cutting with foam tool. Okay, cutting with foam tool. Cutting with foam tool. Okay. The next one, thread cutting. Generating threads. Generating threads on the pieces. The thread cutting operation is used. Okay. The cutting tool, the thread cutting tool is used. Screw cutting. Okay. Next one, the cutting of kind of narrow tool is used for the parting off operation. Cutting off. The last operation I am going to introduce, the knurling operation. Okay. Roller, the cutter is a roller. The surface pattern imprint of the roller is rotate contacting with the surface of the workpiece. Then the surface pattern imprint on the whole knurling operation. Okay, these are the operations we are going to discuss. These are the most common lathe operations done on the lathe machines. Turning operation, facing operation, taper turning operation, profiling, external grooving, face grooving, boring operation, central drilling operation, foam tool operation, screw cutting operations, parting off operation, also called the cutting off operation, and the knurling operations. Okay, let's see first operation, the turning operation. Okay, turning operation. Turning operation done on the lathe machine. Okay. Okay, in turning operation, used to reduce the diameter of the workpiece. Okay, or to obtain a cylindrical surface for the component we are machining. This operation is done. Okay, this is this operation is also categorized the taper turning and the straight turning. Here we are discussing straight turning operation. Okay. Okay, straight turning operation we are discussing. Okay, this is the cutting tool. This is the cutting tool. This cutting tool is rotate against the workpiece. Rotate against the cutting tool to remove this layer. This is the rotating axis of the workpiece. With the rotating axis of the workpiece, then the cutter is fed. Cutter is fed parallel to the rotating axis of the workpiece. So it used to reduce the diameter of the workpiece or to obtain cylindrical surface for the component. Okay, cylindrical shape for the component. For example, let's take this kind of irregular shapes. We are having irregular shape shaft. To obtain the by removing this kind of layer, we are going to obtain we want to obtain cylindrical shape. The operation is we can use the turning operation on the lathe machine. Okay, in turning operation, this end is clamp on the lathe chuck. Then if it is a lengthy workpiece, the front end is supported by the tailstock. Okay, so then by moving the cutting tool from this end to this end, we can remove these layers from the workpiece and we can obtain the required diameter for the workpiece. This operation is called turning operation. Okay. Then next we are going to discuss phase in operation. Okay, phase in operation. Phase in operation. Second operation we are going to discuss is the phase in operation. The phase in operation used to generate the flat surface. Let's take we are having this kind of irregular end for the shaft. Then we want to generate the flat surface by removing this layer from this surface. So the operation we can use is the phase in operation on the lathe machines. By moving the in lathe machine operations in phase in operation, this is the rotating axis of the workpiece. The cutter is fed perpendicular to the rotating axis of the workpiece. Cutter is fed perpendicular to the rotating axis of the workpiece. Then we can remove this material to get the finally we are getting this kind of flat surface which is normal to the this is the rotating axis which is normal to the rotating axis of the workpiece, called the phase in operation. Okay, phase in operation. In a phase in operation, workpiece that in the carriage is clamp on a lathe bed, then a cross side feed hand wheel is used to feed the tool. But in turn in operation, carriage hand wheel is used to feed the tool. Okay, this is the turn in operation and the phase in operation. So let's see the next operation, taper turning operation. Okay, here we discuss turning operation, the phase in operation. Then next one we are going to discuss taper turning operation. Okay, taper turning operation. In taper turning operation, cutter is fed at an inclined direction to get this kind of conical shape for the component. There's a three method you can use to feed the tool in inclined direction. The one is using the tilt in the compound rest. The second one is offsetting the tailstock center. The third one is the by using the taper turning attachment. Okay, then this is the cutting tool. So here I'll explain the use of compound rest. Here this is the rotating axis of the workpiece. Then this is the cutter moving direction. Cutter is fed along this direction. Then we can obtain this kind of conical shape for the component we are machining. Okay. This is the cutter is fed. This operation is called taper turning operation. Okay. Next operation, profiling. Okay. Next operation is profiling. Okay. This profiling operation used to generate the irregular shape for the components we are machining. For example, let's take this kind of irregular shapes between shapes. This kind of shapes you want to manufacture. Okay. In this situation, there's no perfect method to manufacture this component using the lathe machine, the conventional lathe machine. In this situation, the tool have to move simultaneously in y direction and also the x direction to get the required geometries. There's no method to automatically feed this tool to cut this kind of profile. It has to manually feed. It has to manually feed to get the required geometric shape. That means certain skill is needed to obtain the required geometries. Some gauges are used to, some situation the gauges are used to take the exact profile required. Okay. The next operation we are going to discuss is external grooving. Okay. External grooving. Generating a groove on externally is called external grooving. That means on the cylindrical component, generating this kind of groove on the cylindrical component is called external grooving. Okay, you can see the groove. That means if you draw the three-dimensional view, generating this kind of a groove with this kind of a groover. Generating this tool is used. The narrow tool is used. The always in most of the cases the parting tool is used. The cutting tool. Okay, the rotate in this direction. This is the rotating axis of the lathe machine. Okay, then the next one, the face screwing. Okay, next one, the face screwing. Okay, generating a groovers on the face. Generating the groovers on the face is called the face screwing operation. That means this kind of groovers, if you look from the cross-sectional view, it's like this. Okay, if you look the 3D view, in this kind of shape. Sorry, this kind of groovers. Okay, generating this kind of groover is called the face screwing operation. Okay, in this situation the cutter is fed along the rotating axis of the workpiece. Here this is the rotating axis. The cutter, again the narrow tool is used for this operation. Narrow cutting tool is used for this operation. The cutter is fed along the rotating axis of the lathe machine. Okay, this is the face screw. Then boring. The boring operation. Okay, enlarging a existing hole is called boring operation. Enlarging a existing hole is called the boring operation. The boring tool is used for this enlargement. This is the cutting tool. This is the boring tool. It is connected to the boring bar. This is called the boring bar. Then the tool movement is in this direction using the cross slide feeder. Then this diameter can enlarge by removing this layer from the workpiece, called the boring operation. next operation we are going to discuss is the center drilling operation. Center drilling operation. Center drilling operation is used to generate the hole along the workpiece. Okay, this is the workpiece. Okay, to generate the hole along the, this is the rotating axis, to generate the hole along the rotating axis of the lathe workpiece. So, see the cutting tool, drill bit. Okay, this drill bit is mounted on the drill chuck. Drill chuck is mounted on the tailstock. Okay, drill chuck is mounted on the tailstock. This is the drill bit. To generate the hole along the rotating axis of the workpiece, the called center drilling operation. Okay. Next operation we are going to discuss is next operation we are going to discuss is foam, cutting with the foam tool. Okay, it's called the foam turn-in operation. Foam turn-in operation, also called the foam turn-in operation. Let's take the foam turn-in operation. Okay, foam turn-in operation to generate this kind of certain pattern shapes. This kind of shapes we can use you can cut this shape at once using the foam tool. If you can manufacture a tool having this kind of shape, opposite shape of the surface pattern there, then we can cut this entire geometry at once. No, we can cut by feeding the tool in this direction. We can cut this shape. The foam tool operation used for mass production because the tool manufacturing cost is very high, so it's suitable only for the mass production and also the low hardness material. So we can use the foam tool with the higher hardness material because when a large area is contacting with the cutting tool, so very high force is acting on the cutting tool, so it's suitable for soft material like wood, plastic, polymers, and also the low strength aluminum, copper like metals. Okay, foam tool operation suitable for mass production only. Okay, then next one, thread screw cutting, thread cutting. Next operation is thread cutting. Thread cutting operation. Thread cutting operation generating threads. Theoretically, the lathe machine can use to cut any type of thread, but there's a practical limitations depending on the type of lathe machines and its capacity. Theoretically, the lathe machine can use to cut any type of threads. We are having the separate section to discuss this thread cutting operation on the lathe machines. Okay. Then thread cutting tool is used. 55-degree or 60-degree nose radius is used. With the thread cutting, in thread cutting operation, lead screw is engaged to synchronize the rotation and the tool movement. That means this tool feeding and this RPM should be synchronized. What is the synchronization? Per one revolution, this tool have to travel one pitch value. That means per one revolution, if the screw having the one pitch P, per one revolution of the workpiece, tool have to move pitch value. That is the synchronization. This is done using by connecting this spindle with the cutting tool through the gear train and the lead screw. Okay, thread cutting operations. Then the parting of operation. The parting of operation next one, the cutting of operation. So, operations, cutting of operations mean to separate the part. To separate the part, we are using this cutting of operation. The parting of operation, sorry, this kind of this kind of a narrow tool is used for the parting of operation. This kind of narrow tool is used for the parting of operation. The cutting of, to separate the part, or to separate the right hand side part, the cutting of operation is used. Okay, the last operation we are going to discuss is knurling operation. Okay, knurling operation used to generate the surface pattern on the workpieces. Okay, you may have seen the hand tightening screw. There's a rough surfaces to generate this kind of a rough surface. You may have seen this kind of rough surface for the hand tightening screws, and also some conveyor rollers are roughened using the knurling operation. Then this operation is done by rotating this workpiece with contacting with the roller cutting tool. This roller cutting tool having the surface pattern. Then while rotating this roller with contacting with the workpiece, the surface pattern imprint on the workpieces. Okay, the greater pressure is applied. So then this surface pattern on the this roller imprint on the surface of the workpiece. Okay, this is called the knurling operation. Especially the hand tightening screw and also the conveyor rollers are roughened using this knurling operation. These are the common lathe operations done on the lathe machines. Okay.